Okay, some of this homework is from yesterday. We talked about independent and dependent events. What's the difference between independent and dependent? Independent is if I gave you a deck of cards, independent, and I said pick a card, and if you replaced it and you have the same number of cards that when you started with, then those are independent. If you pulled a card and did not replace it and then you picked another card, those are dependent. So if the second event depends because you don't have the same number in your sample space, those are dependent. Okay, so number one, this one's a little confusing. A member of the junior class is selected and one of her pets is selected. That one is dependent because it depends on who's selected. Number two, a member of the junior class is selected as the class president, and then a freshman is selected as freshman class president. Does it matter who you pick as a junior? So these are independent. Independent events. I spelled that wrong, right? No, I guess I did spell it right. Independent. Okay, number three. An odd numbered problem is assigned for the homework. An even number problem is picked for a test. Is that independent or dependent? Does it matter what you pick here? Is it going to affect this even number? No, those are independent. Number four, the sum of two rows of a number cubed is 6, and the product is the same two rows. The product of the same two rows is 8. That's dependent. Now, if two events are independent, do you remember what you do with these two? They're not mutually exclusive, they're not inclusive, they are independent, you multiply the two. So what is 1/8 times 2/5? What do you get? What's 1/8 times 2/5? 1/20. What is 0.8 times 0.2? These are all independent. 0.8 times 0.2. 0.16. Number 7. We have 1/4 times 1/5. Quickly. 1/20. Not 2/20. You're multiplying. And the last one, what's 3/4 times 2/3? 1/2. Questions? Independent, of two events, you multiply the two. So here's a story problem relating to these. Suppose you have 7 CDs in a box. We have 4 rock, 1 jazz, and 2 country. So 4, 5, 6, 7. Today you're going to choose 1 CD without looking, and you're going to play it and put it back. And the next, you're going to put it back. The next day you're going to pick another CD and play it. What is the probability that both CDs are country? Well, how many are country? 2. 2 out of what? 7 times you're putting it back. 2 out of 7. What do you get? What's 2 over 7 times 2 over 7?
49.
Yep. Okay, next, we're going to talk about whether these are, if they're mutually exclusive or not. Mutually exclusive means, can you have these two things happen at the same time? So, 10. Can you give me an integer that's less than 40 and greater than 50? So this is mutually exclusive. The probability probability of doing something that's less than 40 and greater than 50 is 0. But what you would have to do is turn this to an integer less than 40 or greater than 50. Okay, that's how, we're not doing that, but we're just telling whether you can have it at the same time or not. How about the next one? If the integer is odd, can the integer be a multiple of 4? No. Mutually exclusive. How about 12? The integer is less than 50, and the integer is greater than 40. Can you have something less than 50, but bigger than 40? This is called inclusive. Inclusive, there are numbers that are greater than 40 and less than 50. So now, if they are mutually exclusive events, we turn it into an or problem, because if it was and, it's not going to work. Like, you can't have a number that's 3/4 and 1/6. They're not the same. So if I told you two events are mutually exclusive, what do you do with these two probabilities? We just talked about it. You add them. So what's 3/4 plus 1/6? What do you have to do to these two? You got to get a common denominator. So this is going to be 9/12 plus 2/12, which is 11/12. How about the next one? That's easy. What's 10% plus 45%? Good. Next one. What's 20% plus 18%?
38.
And how about 1/10 plus 3/5?
17.
Yep, 7/10 or 70%. Flip it to the back. Here's an easy one. These are mutually exclusive. Exactly 62% of the students at your school are under 17 years old. In addition, 45% of the students are over 18. So you can't be under 17 and over 18 at the same time. They're mutually exclusive. So what is the probability that a student chosen at random is under 17 or that? So these are mutually exclusive. What do you do with these 2%? You add them. What do you get? What's 62% plus 4%?
60%.
66%. Okay. All right, the next 4, okay, can you roll a cube and get an even number and a 3? It's mutually exclusive, right? So what you're going to do is figure out what's the probability of getting an even number. How many even numbers are there on a cube? 3. How many are 3? How many numbers, on a cube, how many 3s are there?
4.
There's 1, so this would be 4/6 or 2/3. Okay. Can you get a number less than 2 and it be even? No. That's mutually exclusive. So what's the probability of a number less than 2? 1/6. How about even? And you get 4/6 or 2/3 again. Can you roll a prime and a 4? No. So these are mutually exclusive. So what's the probability of a prime number? We have 2, 3, and 5.
3.
How many 4s are there? So this is going to be 4/6 or 2/3. Next one. You randomly choose a natural number from 1 to 10. What's the probability that you choose a multiple of 2 or 3? Probability of a 2, probability of a 3, and is this mutually exclusive or inclusive? Can you pick a number from 1 to 10 that is a multiple of 2 and 3? Isn't 6? So this one is inclusive, so you have to do the probability of 2 and 3. So how many numbers from 1 to 10 are multiples of 2? We have 2, 4, 6, 8, 10. So 5 out of 10. How many are multiples of 3? 3, 6, 9. And how many are multiples of 2 and 3?
1.
Only 1. So what's this answer?
7, 10.
Yep, 7 tenths. Okay, I want you to finish these 22 through 29 for homework. Okay? Emma, you can your math.